Hey guys, let's doing a video now on Simpson's rule. This is a really weird thing that I never heard of before until I did this did the questions here. But it's another way of approximating the area of an irregular shape. So in the previous questions you were approximating the area of a regular shape using a known shape, one of the simple ones that we know about. And you're just going, oh okay, that regular shape is the same shape as a triangle, so I'll use a triangle to estimate its area and then find the approximate area. Whereas here, they can be really weird shapes. It involves these things called offset lines, which will be illustrated soon. They start at the edges of the irregular shape and are drawn across the shape at regular intervals, and there's always an odd number of them, I believe. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, yep, there's an odd number in my diagram below. It doesn't work properly when there's an even number. So what's the rule here? Well, the rule is cars coming past. The rule is as given in your book. Area is equal to W over 3 times by all in brackets. And these things here, that letter there is L. Okay, so it's length 0 plus 4 times length 1 plus 2 times length 2 plus 4 times length 3 plus 2 times length 4 plus on and on and on. It doesn't matter how many divisions you've made, okay, because these L's represent the offset lines that are drawn. You're going to get a more accurate area if you have more offset lines. But basically, these are the lengths of the offset lines, and it follows this pattern. The first one is just the straight length of the very first offset line at the edge of the diagram. Then you add 4 times the next offset line plus 2 times the next offset line, and then 4 again times by 2 again, and then this pattern goes on. But you just need to make sure that the very last, because it's going to be an odd number of offset lines, the very last offset line is going to be not multiplied by anything, and the second to last will be multiplied by 4. So this pattern is going to go on. It's going to go no number 4 2 4 2, and then all between here it's going to go 4 2 4 2. Okay, that's going to continue, but you need to ensure that when the pattern ends there is no number to multiply ln by, the very last offset line, and the second to last one has to be 4. Okay, so just to go over that one more time because it's quite complicated, where the n here stands for the total number of offset lines, so you have to finish on the very last offset line. It's going to be the edge of your diagram. L is the length of those offset lines, so you're going to be given a measurement there, or you have to measure it yourself. And W is going to be the width between the offset lines. So these offset lines have been drawn evenly across the diagram. W is going to be the same width between them all. So just to point out how that relates to this, W down here is this. It's the width is even between all of the offset lines. Length 0 is going to be however long that line is. Length 1 is going to be multiplied by 4 there. Length 2 is going to be multiplied by 2 there. Length 3 is going to be multiplied by 4. Length 4 multiplied by 2. Here's the in-between bit, so length 5 would have to be multiplied by 4. Length 6 would have to be multiplied by 2. And length 7, because it's the second to last, it's going to have to be multiplied by 4. And just notice that there's 8 offset lines, and n take 1, or the number of offset lines takes 1 is going to be 7. Line 7 is going to be multiplied by 4, and line 8, the last offset line, is going to be multiplied by, well, nothing. It's just going to be itself. Okay, so that looks quite confusing. It was quite confusing for me when I first saw it doing the exercises, but in practice it's not too bad. Basically you just plug everything that you know into the formula. So the area, you just need to also make sure that you are indicating that you're going to be approximating. Alright, so you look at this diagram, looks like a fish. It's been evenly divided into 10 centimeter sized widths. Okay, and where is L0? L0 is going to be there. L1 L2, L3, 1, 2, 3, 4, and L4 here. Okay, so what's the width? What's W? It's going to be 10 over 3. And then the brackets start. Length 0 is 10 centimeters. Is it multiplied by anything? No. Plus the next one has to be 4 times whatever the length is, which is going to be 8. Plus next length is going to be multiplied by 2 lots of 20. Plus length 3 is 18, and that is the second to last offset line, so it has to be multiplied by 4 lots of 18, plus the last offset line is not going to be multiplied by anything, and in this case, because the fish ends in a point, it has no length at all, so it's going to be 0. So we're going to have, I just need to grab my calculator. So, red mass, need to work out the brackets first. 10 over 3 times by 10 plus 4 lots of 8 plus 2 lots of 20, 40 plus 4 lots of 18, 72 plus 0. Still haven't worked out the bracket. 10 over 3 times by 10 plus 32 plus 40 plus 72 plus 0. 154. So we worked out the brackets. So that is going to be 10 divided by 3. And then times that answer by 154. It's going to be 513.33 centimeters squared, or square centimeters to 2 decimal points approximately. Okay, so just remember that is an estimation. So yeah, hopefully that helps you out in how to work out these Simpson rules problems. There's quite a few of them. It's quite awkward, I've never seen this before, but it's pretty easy when you get the hang of it. So I'll see you in the next video.